electrons move from cathode to anode, setting up the flow of current from anode to cathode. This mode of operation is called as forward bias, and this current is called as a drift current. In the second case, we apply the battery in reverse direction. That is, we apply positive of the battery to cathode and negative of the battery to anode. As a result, holes are formed towards the negative of the battery and electrons from N side are pulled towards positive of the battery. Thus holes and electrons move away from the junction, which leads to an increase in the depletion region width. No current flows through the diode. This mode is called as reverse bias mode. But there are some minority charge carriers always present in both the regions. Hence, in the reverse bias case, minority charge carriers cross the depletion region, setting up the current flow. But magnitude of this current is very low, in nanoampere range. Ideally, in the reverse bias mode, current through the diode must be zero. But practically, we get some current which is called as the leakage current. Let's study the characteristics of this diode. This graph is drawn by considering external applied potential on x-axis, current flowing through the diode on y-axis. When the diode is operated in forward bias mode, current flowing through the diode between A and B remains at a low level. But as soon as the external voltage crosses the junction potential value, or cut in voltage, the flow of the current rises from point B and point C. This graph is called as the forward characteristics of a diode. When we connect the diode in reverse bias, the leakage current flows in the opposite direction till point D. But if we further increase the reverse voltage applied at one point, diode breaks down and a large amount of reverse current flows through it, which may damage the component. This value of reverse voltage is called as the breakdown voltage. In order to prevent our diode from breaking down, the diode should be doped in a very controlled manner. When an ordinary diode is heavily doped so that it has a very sharp breakdown voltage, it is called as the Zener diode. Thus, in the Zener diode, the breakdown voltage is accurately adjusted to make it withstand in the reverse biased mode. Hence, the Zener diode works effectively in reverse bias also. Due to this special characteristic, the Zener diode finds many applications in the voltage regulator circuits.